Students, in previous class we learned trigonometric ratios of compound angles. In this class we will learn trigonometric ratios of multiple and submultiple angles. So on the completion of this period you would be able to understand the properties of trigonometric functions of multiple and submultiple angles. State and prove the identities of trigonometric functions of 2a in terms of a and a in terms of a by 2. 3, 6, 9, 12, 15, 18 this series. What types of numbers are these? Multiples of 3. 56, 28, 14, 8, 7, 4, 2. What type of the numbers are these? Divisors of 56 are submultiples of 56. Similarly, 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 dash are multiple angles of 10 degrees. 24 degrees, 12 degrees, 8 degrees, 6 degrees, dash are submultiple angles of 24 degrees. If A is an angle, then 2A, 3A, 4A, 5A, dash etc. are called multiple angles of A. And a by 2, a by 3, a by 4, dash etc. are called submultiple angles of A. So sin of a plus b equals to sin a cos b plus cos a sin b. We know these formulas in previous chapter. Cos of a plus b equals to cos a cos b minus sin a sin b. Tan of a plus b equals to tan a plus tan b by 1 minus tan a tan b. Cot of a plus b equals to cot a cot b minus 1 by cot b plus cot a. Expressing sin 2a in terms of sin a, we have sin a plus b equals to sin a cos b plus cos a sin b. Substitute b equals to a, then it becomes sin of a plus a equals to sin a cos a plus cos a sin a. That is sin 2a equals to 2 sin a cos a. Expressing sin 2a in terms of tan a, we have sin 2a equals to 2 sin a cos a. Multiply and divide RHS by cos a. So sin 2a equals to 2 sin a cos a, and here multiply and divide cos a. So sin a by cos a is tan a. Cos a into cos a, cos square a. So cos square a, if we write in reciprocal, it means inverse, we can write 1 by sec square a in place of cos square a. Then sec square a, we can write 1 plus tan square a. Therefore sin 2a equals to 2 tan a by 1 plus tan square a. Express cos 2a in terms of cos a. We have cos of a plus b equals to cos a cos b minus sin a sin b. Substitute b equals to a. Cos of a plus a equals to cos a into cos a minus sin a into sin a. Then cos 2a equals to cos square a minus sin square a. Expressing cos 2a completely in terms of cos a, we know that cos 2a equals to cos square a minus sin square a. In place of cos square a, we can write 1 minus sin square a. So remaining sin square a write as it is. So sin square a and sin square a, 2 sin square a. Therefore 1 minus 2 sin square a. Express cos 2a completely in terms of sin a. We have cos 2a equals to 1 minus 2 sin square a. Cos 2a equals to 1 minus 2 into, in place of sin square a, we can write 1 minus cos square a. So 1 minus, multiplying with 2, we get 2 cos square a minus 1. So here, see the heading. This is the cos 2a complete in terms of sin a is given, but it is actually cos a. express cos 2a terms of tan a in terms of tan a. See, any angle we can express in any trigonometric ratio. That is the point. We have cos 2a equals to cos square a minus sin square a, and take the 1 in the denominator, and in place of 1 we can write cos square a plus sin square a, and divide and multiply with cos square a. So otherwise don't do divide and multiply, just take a common cos square a from numerator and denominator. Then we get like this, 1 minus tan square a by 1 plus tan square a. So finally we say cos 2a equals to 1 minus tan square a by 1 plus tan square a. So here cos 2a is expressed in sin a and in expressed in terms of cos a and also tan a. So there is no issue, because using the ratios formulas we can express in any term. Express tan 2a in terms of tan a. Tan a plus b equals to tan a plus tan b by 1 minus tan a tan b. Substitute b equals to a. So tan of a plus a equals to tan a plus tan a by 1 minus tan a into tan a. Therefore 2 tan a by 1 minus tan square a. Then cot 2a in terms of cot a. Cot of a plus b equals to cot a cot b minus 1 by cot b plus cot a. Substitute b equals to a. So cot of a plus a equals to cot a into cot a minus 1 by cot a plus cot a. That is cot square a minus 1 by 2 cot a. If you observe the present learnt formulas, sin 2a equals to 2 sin a cos a, that equals to 2 tan a by 1 plus tan square a, and cos 2a equals to cos square a minus sin square a, and that equals to 1 minus 2 sin square a, and that equals to 2 cos square a minus 1, and that equals to 1 minus tan square a by 1 plus tan square a. Tan 2a equals to 2 tan a by 1 minus tan square a. By seeing above, we can write sin a equals to 2 sin a by 2 into cos a by 2. Here left side, in place of 2a we took a. So in the right hand terms also changes occurs. In place of a, it is also reduced. So in place of a we wrote a by 2. And similarly in another terms also, 2 tan a by 2 by 1 plus tan square a by 2, and cos a also, cos square a by 2 minus sin square a by 2, and that equals to 1 minus 2 sin square a by 2, and that equals to 2 cos square a by 2 minus 1, and that equals to 1 minus tan square a by 2 by 1 plus tan square a by 2, and tan a equals to 2 tan a by 2 by 1 minus tan square a by 2. So let us see the problem. Find the value of cos 22.5 degrees to 45 degrees 22 minutes 45 degrees comma 22.5 degrees is a submultiple angle. We know that cos 2a equals to 2 cos square a minus 1. Substitute a equals to 22.5 degrees. Then cos 45 equals to cos of 2 into 22.5 degrees, that is cos 2a means 2 cos square a minus 1. So we write 2 cos square of 22.5 degrees minus 1, that is 1 plus cos 45 equals to 2 cos square 22.5. So 2 cos square 22.5 degrees equals to 1 plus cos 45 means 1 by root 2. So root 2 plus 1 by root 2, after LCM we get. So cos square 22.5 equals to, and Cos 22 and a half degrees equals to square it goes to the right side, it becomes a root, square root. Similarly, find the value of sin 22 and a half. We have cos 2a equals to 1 minus 2 sin square a. So substitute a equals to 22 and a half. Then cos 45 equals to 1 minus 2 sin square 22 and a half. And 2 sin square 22 and a half equals to 1 minus cos 45. So substitute the cos 45 value, then we get sin square 22 and a half degrees, then after sin 22 and a half degrees. Like, see here, you can find the value of tan 22 and a half degrees also. And also you observe, find the value of cot 22 and a half degrees. And like sin 67 and a half degrees. So, and see the example problems. Prove that sin 2 theta by 1 minus cos 2 theta equals to cot theta. Take LHS. In place of cos 2 theta, we can write 1 minus 2 sin square theta, and after expansion we get cot theta. So this is got RHS. Another example, prove that tan 2 theta by 1 plus sec 2 theta equals to tan theta. Take LHS and convert into a tan as a sin by cos, and sec we can write 1 by cos, and after LCM we get sin 2 theta by 1 plus cos 2 theta, and sin 2 theta formula we have to write, and cos theta formula also we can write. Then we get the sin by cos, that is represents RHS. Like this, we can see here another example, prove that. See here also we are using the formulas. See, this is a printing mistake, that is sin 2 theta, not 2 sin theta. Sin 2 theta equals to 2 sin theta cos theta. Take LHS and substitute that sin 2 theta formula and simplify, and we get RHS. And see another example. If sin A equals to 4 by 5 and A is acute, find sin 2A. So we know cos square A equals to 1 minus sin square A. From that we get cos A, and from sin 2A formula we will get the sin 2A value. So today you learn the following formula: sin 2A, cos 2A, and tan 2A, and cot 2A. And also submultiple angles how to find, that is sin 22 and a half degrees, cos, tan. And after reading or knowing the formulas, you can easily solve these quiz questions, and I am giving previous exam questions, so do it and try to do exercise problems. I know, once again I am saying, before watching video, see the PPT in another device, because every video is given with PPT. So sometimes screen clarity may miss in a video, so that have PPT along with video, then you can easily understand the lesson. Thank you.